Okay, so in the eighth day, we reach a patch of trees that was planted in a previous expedition by the elves. This time, they think that it would be a good idea to build a tree house in this location, but to determine whether there is enough tree cover to keep the tree house hidden, they have to count the number of visible trees from the outside. So they map the tree heights and give us the puzzle input. The puzzle input consists of the heights of each tree in the patch. A tree is visible if it's tall enough to be seen from the outside. So in the example input, the tree from the location 1, 1 with a height of 5 is visible from the top because there is another tree with a height of 0. It is also visible from the left because there is a tree with a height of 2, but it's hidden from the right side and from the bottom because there are some trees with the same height. But overall, the tree is visible because it is visible from two sides. Another example would be the tree with height 4 from the right bottom corner, which is hidden because in any direction you would look, there is another tree with a larger height. So to the right is a tree with height 9. From the top there is a tree with height 7. From the left there is a tree with height 5, and from the bottom there is a tree with height 9. Also, all trees from the edge are visible. So then for the second part, because the tree coverage is high enough, the elves are happy to build a house. To choose the location of the house, they want to have as much viewing distance as possible. To compute this viewing distance, they will choose a tree from the patch and they will look in all four directions to see how many trees are visible from that spot. So for example, let's say that we choose the tree with height 5 from the coordinates x2, y1. If we look towards the north, we can see only one tree with height 3. If we look towards the left, we can see only one tree with height 5. The other tree is hidden because of that tree. If we look towards the right, we can see another two trees, and towards the bottom we can see another two trees. The last one is hidden again because of the tree with height 5. The elves also give to each spot a score, and the score is computed by multiplying all the viewing distances. So for this example, it would be 1 times 1 times 2 times 2, which is 4. Our goal for this question is to find the highest scenic score. For the solution, I have converted the entire input into a vec of U8 into a 2D array of digits. Then for the first part, I have iterated through all the spots, and if that spot was visible, then I increased the counter. So as explained in the problem statement, I have considered visible all the trees on the edges. So when x is 0 or it's equal to the line length, or when y is 0 or it's equal to the line length. Then I iterated in all four directions from the current position, and I used a fold to decide whether the given direction would make the tree visible. So for example, the first range would represent the coordinates of the left hand side trees. Then the fold would have a starting value of true, and then for each tree we would have to AND together the accumulator and the condition that the tree that we are interested in has a height larger than the tree that we are currently checking with. And then we do the same thing for the right hand side trees, then for the trees at the top and the trees at the bottom of the current tree, and we OR together all the conditions. For the second part, I also used two for loops to iterate over all the trees, and I created a best variable to hold the highest scenic score. To compute the scenic score, again from the problem statement, it says that when a tree is on the edge, it will have a score of 0 because there are no trees visible in one of the directions, and the multiplication would be 0. Then I again iterated in each of the four directions, but this time I did it outwards, so from the center towards the edge, and I used this take until function, which works similarly to take while, but it stops after it meets the given condition. So for example, for the left hand side trees, we would start from the center and we would move towards the edge, and when we find a tree that has the same or larger height than the tree that we consider for building the house, we stop and take the count. And then we do this for the other three directions and we multiply the scores to get the scenic score. And to have access to the take until function, I have used this take until crate. To be honest, I was too lazy to implement it myself, so I just took it. So yeah. And yeah, this was the 8th day. It was pretty interesting, and yeah, the same as before. If you want to check out the code, you can access it on my GitHub, and see you guys next time.